The University of KwaZulu-Natal's College of Agriculture, Engineering and Science is committed to making a difference in our world, from the classroom and laboratory to the field. It provides one of the finest study and research environments on the African continent and is recognized internationally as a center of excellence. Agriculture, Engineering and Science is one of 4 colleges that make up the University of KwaZulu-Natal and is home to over 8,700 students and approximately 700 staff. 3 of the university's 5 campuses form the core of agriculture, engineering and science activities in the region. The college comprises 5 schools: agricultural, earth and environmental sciences, engineering, chemistry and physics, life sciences and mathematics, statistics and computer science. Engineering is offered on the Howard College campus, agriculture on the Pietermaritzburg, and all the other sciences on both the Pietermaritzburg and Westville campuses. Exceptions are agricultural engineering, which is offered in Pietermaritzburg, and geology, which is offered at Westville only. To compete with the best and to meet the challenges of the 21st century, South Africa needs highly skilled professionals in the areas of agriculture, engineering and science. We offer a wide array of interesting and innovative degree programs that open doors to a variety of different careers. Some degrees are unique to UKZN and are not offered at other tertiary institutions. For example, we are the only university in South Africa to offer a fully accredited agricultural engineering degree and one of only 2 universities in the country to offer a BSc in land surveying. Our postgraduate food security training program is the only one in the world, and we have the widest range of agricultural disciplines at any single South African or African campus. The choices of degree and the options on offer may seem confusing at first. Engineering degrees are more specific, and the options are usually career-focused. Emphasis is placed on training in the specific principles which engineers deal with in their professions. Engineering offers 7 different professional specializations. There are also degrees in land surveying or geomatics and property development. In science, there are structured or career-focused degrees. These include fields as varied as chemical technology, marine biology, industrial and applied biotechnology, and computer science and information technology, to mention a few. There are also more general degrees with a lot of flexibility. In this case, students have the choice of studying a BSc M stream in maths, physics, computer science, and statistics. All of these have a strong mathematical component. The other option is a BSc LES stream with a focus on the life and environmental sciences with subjects such as geography, genetics, botany, hydrology, zoology, ecology, and microbiology. In agriculture, there are various different options that involve practical and scientific applications. Students can combine science subjects with specific agricultural disciplines, for a 4-year Bachelor of Science in Agriculture degree. These are more career-orientated. Agriculture and agricultural management are 3-year degrees with a higher practical component. Dietetics is a professional qualification that deals with the role nutrition plays in the promotion of
Where's
health
connection?
and the treatment of disease.
Also raise excitement.
Most degree programs across the college have field trips and projects that contribute significantly to the curriculum. This ensures that students learn in real-life situations. Many of our lecturers have received Excellence in Teaching awards, are recognized internationally, and are rich in practical experience. Students have access to excellent facilities that rank amongst the best in the world. 300 million rands has recently been invested in new teaching and research facilities, state-of-the-art laboratories, and improved equipment. The 30 million rands new School of Engineering building is the envy of engineering campuses across the country. Agricultural students have access to a 356-hectare research and training farm situated near the Pietermaritzburg campus. This facility provides students with hands-on training and is used extensively as an outdoor laboratory for teaching and research in areas such as animal and poultry science, horticultural science, and agricultural engineering. Adjoining Ukulinga is the Bisley Valley Nature Reserve, which supports a diversity of plant and bird species, as well as some large mammals. It provides a rich learning and research environment for staff and students. Based on the Western campus, the college possesses unique facilities for research into higher voltage power transmission. These facilities are available in only 3 other places in the world and form part of the ESCOM-sponsored Science and Technology Innovation Park. The Science and Technology Education Center showcases the college's scientific achievements and promotes the public understanding of science, engineering, and technology within the region. The college houses a wide range of sophisticated equipment in its microscopy and microanalysis units, staffed by highly qualified and skilled technical specialists. The College of Agriculture, Engineering, and Science prides itself on its graduates who are highly sought after. In a market characterized by a shortage of qualified professionals in science and technology, our graduates are readily employed around the world in the fields of agriculture, science, commerce, industry, engineering, and research, to name just a few. Research plays a major role within the college and operates at the cutting edge of technology. College has the highest research output in the university and produces the most research publications. There are over 60 well-established research groups and centers within the college. The African Center for Crop Improvement caters for students from all over Africa. It is one of only 2 African plant breeding programs on the continent. Based in the School of Agricultural, Earth and Environmental Sciences, the African Center for Food Security focuses on alleviating hunger in Africa. It offers food security training programs, undertakes academic and applied research, and provides policy and program support. Promoting sustainable engineering practice is the Center for Research in Environmental, Coastal and Hydrological Engineering, or CRESH. It deals with the interaction between engineering and the natural environment. The Mechatronics and Robotics Research Group in the School of Engineering provides an excellent research and education environment for its senior undergraduate and postgraduate students. Judged one of the best research centers at the university, the Center for Plant Growth and Development focuses on high-quality research in the plant-based disciplines of plant physiology, plant molecular biology, and ethnobotany. The Center for Quantum Technology deals with physical phenomena at the microscopic level. Quantum physics led to the development of the transistor and the laser, and is currently being used to develop quantum computers and quantum cryptography. The college is committed to access and readdressing the disadvantages and inequities of the past. The highly successful Unite Engineering program and the Science Access Foundation and augmented programs offer alternative access to university, equipping students from disadvantaged backgrounds with the skills and knowledge to pursue their degrees of choice. Both these programs contribute significantly to advancing Black African scientists and engineers in South Africa. Staff and students contribute to a number of outreach and community initiatives that focus on social responsibility, sustainable development, and activities involving the pursuit and understanding of science, engineering, and technology through exhibitions, festivals, and roadshows that target high school learning. The college has minimum entry requirements for its programs. These differ from degree to degree, but all require a national senior certificate and minimum performance levels in mathematics and either physical or life or agricultural sciences. For those who do not meet the minimum requirements, access programs are available. Additional information and brochures can be obtained from the contact information accompanying this video. The College of Agriculture, Engineering and Science is proud of its contribution to the university, the region and the country.
UKZN is one of the best. I definitely understand it's one of the best in South Africa. So for me, there was no other institute that I would have preferred other than UKZN.
We have the best facilities here in terms of laboratories, in terms of equipment, in terms of human resources, in terms of literature.
UKZN is one of the best universities in the country that teach agriculture or natural sciences.
What I think is good about this college is the level of so a great international standard.
UKZN has got much more facilities and it's recommended worldwide to do your science studies here. Life begins here. Yes.
We continually strive to be academically excellent, innovative in research, and critically engaged with society. We invite you to join us or work with us to be part of this exciting.
Hi everyone, welcome back to the second session. So today we will be continuing with the functions that we left off with last time, and then we're going to move on to finance for the second half of the session. Okay, with a short break in between. Okay, so let's get started. So we've got a parabola here, f of x, and we've got a straight line g of x. So let's just have a look at that. So we've got this parabola. Okay, so we've got this parabola here and a straight line. Okay, so the first question here, 5.1, calculate the coordinates of A and B. So we see that A as well as B are the two roots of this parabola. Okay, the two x-intercepts. So what we want to do is take our parabola, minus 2x squared plus 4x plus 16, and we want to set this equal to 0. Okay, so that's how we can find the roots. So first we can divide through by minus 2. So we're going to get x squared minus 2x minus 8 is equal to 0. And this is going to be factored quite nicely as x minus 4 and x plus 2. Okay, now we've got a product of two terms being equal to 0, and that's going to give us our two solutions. So we're going to have x is equal to 4 or x is equal to minus 2. And we can see that since a is on the left-hand side, that should be the negative solution. So a is going to be minus 2 and 0. And since b is on the right-hand side, that's going to take the positive solution. So it's going to be 4 and 0. Okay, 5.2, determine the coordinates of C, which is the turning point of F. Now, we can do this two ways. So for 5.2, we can either complete the square, because if we complete the square, we convert the polynomial into the turning point form, and then from that, we can read off the turning point. Or, since we know a bit of calculus, we know that the turning point is located where the gradient is 0. Yeah, so you can also use that to find the turning point. Okay, so let's start off with that method. Let's say we're going to take the gradient and set it equal to 0. So this will give us the horizontal line at C, okay, because that's the turning point there. So we're going to have, d by dx of minus 2x squared plus 4x plus 16 is equal to 0. We can take the derivative. So we get minus 4x plus 4 is equal to 0. 4x is equal to 4 and x is equal to 1. Okay, so we know the x part is 1, and we can work out the corresponding y part by just saying f of 1. Yeah, that will give you the y coordinates of C. So in this case, it will be minus 2 times 1 squared plus 4 times 1 plus 16. Okay, so that's going to give us 18. So C is then given by 1 and 18. Okay, so that's the first method. We can take the derivative, set it equal to 0, and that will give us the turning point. Or, if you don't like that way, we could also complete the square. Okay, that will give us the turning point. So, or we could complete the square. Okay, now it's always good to know multiple methods, because in an exam situation, you might forget one method. It's always good to have another just in case. Okay, so we begin with our function f of x. That's going to be minus 2x squared plus 4x plus 16. And this is in standard form, your ax squared plus bx plus c. We want to transfer this into that turning point form. So step 1, we isolate the x squared and the x term. So that's going to be minus 2 x squared minus 2x, okay, because we took out a minus 2. And then don't forget your plus 16, we need to carry that down. Next, we need to combine these x squared and the x term into 1. So the way that we do that is we put x minus, and then half of this coefficient. So the coefficient is 2, half of that's going to be 1, and then we square everything. Now, we're not done yet, because if we take a look at this term here, if we square this, we're going to get x squared minus 2x, which is good. That's what we wanted. However, we also get a plus 1 term. Okay, we don't want that. So to correct for that extra term, we need to subtract 1. Okay, so it's a little correction to the fact that we get an extra plus 1 from expanding out the square. And don't forget your plus 16, you need to carry that down still. Okay, so we can distribute the minus 2. So we get minus 2, x minus 1 squared, plus 2 from the minus 2 and the minus 1, plus 16. And this gives us minus 2, x minus 1 squared, plus 18. And from this, we can right away read off the turning point. So C is going to be at 1, 18. Okay, which agrees with what we had before. So that's nice. Now, like I said, it's always good to have multiple methods in mind, just in case you forget one, or maybe another method is easier. Okay, so it could be 2 ways to solve a problem. However, one way could be a lot quicker. Like we saw here, taking the derivative, that was pretty straightforward. Completing the square, it's a lot of in-between steps. You might make a mistake there. Okay, so just keep that in mind when you're looking through these problems. Okay, let's have a look at the next bit. So the graph of H is given by, 5.3, write down the range of F. Okay, so F is our parabola. We see that it's a sad face parabola, so we include everything below the turning points. So for 5.3, it's a sad face parabola. So we include everything below the turning points. Right, because the turning point is the maximum, so you can't go beyond that, so it's everything before. In other words, y is less than or equal to 18. Okay, that's one way of writing it. We could also write it as a set. We could say minus infinity to 18 if you wanted to. Yeah, either way, that's perfectly fine. Okay, so let's look at 5.4 now. So 5.4, the graph of h of x is equal to f of x plus p. Okay, so let's just highlight that. So we've got a shift in the x direction. We also have a shift in the y direction. Okay, so a double translation going on here. Now, this new function has a maximum of 15 at x equals 2. Okay, so that's all the information we need. Because as soon as you see that a parabola has a maximum value of 15, you know right away that that's going to be the turning point. And that's the y value of the turning point. We see that the maximum occurs at x equals to 2. That's the x part of the turning point. So we can easily find P and Q, okay, just by noticing that. So for 5.4, we have that h of x is equal to f of x plus p, so that's a shift in the x direction, plus q, that's the shift in the y. Okay, so we know that this new turning point, so let's write TP, the new turning point is at 15 and 2. So how did we shift from the original turning point to get to this new turning point? Okay, well, let's have a look. H of x is equal to minus 2, x minus 1 plus p, okay, because we're shifting by p, plus 18 plus q. So these are the two shifts that we have added to our expression. Okay, but we know what the turning point is, so we can then solve. So p minus 1 must be equal to minus 2. So p is going to be minus 1. And 18 plus q, this turning point, that's supposed to be the other way around. Sorry, that's 2 and 15. Okay, so 18 plus q, that's going to be 15. So q is equal to minus 3. Okay, so we just compared the old equation and the old turning point with this new equation and the new turning point, and we can see what shift we've made. Okay, so we've shifted horizontally by -1, and we've shifted down by 3. So Q is -3. Okay, let's have a look at the next one, 5.5. Determine the equation of G inverse, okay, which is the inverse of G in the form y equals something. Okay, so let's just remind ourselves what G was. So G of X was 2x plus 4. Okay, that was that straight line. Okay, so for 5.5, we have G of X is equal to 2x plus 4. Now, the way that we find the inverse is we replace the function name with y. So we have y equals 2x plus 4. Then we do a little swap with x and y. So we swap those. Okay, so x has been swapped with y. And then we solve for y. So x minus 4 is equal to 2y. Y is then equal to 1/2 x minus 2. So this is our G inverse now. Okay, so let's just make a little note here. We solve for y, which will be our G inverse. Okay, in this case here. Okay, that's not too bad. Okay, so when you're finding the inverse of a straight line, you're just swapping your x and y and then solving for y, and you should get another straight line in the end. Okay, so it's not too bad. 5.6, for which values of x will the product of G inverse and G be equal to 0? Okay, that's not too bad. We know what G is. We've just calculated G inverse. We can take the product and we can set it to 0. So for 5.6, we want G inverse times G to be equal to 0. That's not too bad because G inverse, we know that that is just 1/2 x minus 2. And G, that was given at the beginning, 2x plus 4. Now, the nice thing about this is that it's already factored, so we don't have to do any factorizing. Sorry, it's already factored. So we've got the two parts multiplied being equal to 0. So that means this first part must be equal to 0. Or the second part must be equal to 0. Okay, one of them must be 0. So for the first part, we're going to have 1/2 x is equal to 2, x is equal to 4. Okay, so that's our first solution. And then for the second solution, we have 2x is equal to -4, x is equal to -2. Okay, so we have two solutions for which the product is 0. Okay, so x equals 4, x equals -2, for which the product is 0. Okay, so that wasn't too bad. We didn't even have to factor anything. Okay, so as I said last time, if you do have any questions while I'm going through the work, please put that in the chat. So we have people there that can assist you with that. If you do have unrelated questions, so not on functions or finance, maybe a different section, there is an email that you can send your questions to. Okay, so just for this session, please restrict your questions to functions and finance. Anything else, we've got a dedicated email line for that. Okay, so that was 5.6. Let's see what's next. 5.7. Okay, we've got a new function p, which is f of x plus k. So we're taking our parabola and we're shifting it up and down by k. So let's just make a little note of what we're doing there. So we're taking the parabola and shifting up or down. Okay, so we don't know what the sign of k is. If k is positive, we're shifting up. If k is negative, we're shifting down. Okay, so determine the values of k for which p and g will not intersect. Okay, so big emphasis on the not intersecting. Okay, so let's see where our g is. So that was this line. Let's put that in green. So what we want to do is shift our parabola such that the parabola and the line do not intersect. Now, you're just going to have to imagine this in your head. If we take this parabola and we shift it up, then it's always going to be intersecting. Okay, because this parabola goes on infinitely downwards. It doesn't matter how much you shift it up, there's always going to be two intersections. However, if we take this parabola and we shift it down, then there's going to be a point at which there's only one intersection. It's going to look something like this. Okay, that's a bit horrible. Let's redraw that. Something like that. Okay, so just imagine we take our parabola, we shift it down, and at some point it's going to be equal at this point here. Yeah, they're going to be equal. One intersection. Now, if we continue shifting down, then there's going to be no intersection. So for this first bit, if we shift down by this first amount, then there is one intersection point. Anything after that, then there is no intersection. Okay, so that's the visual that you should keep in mind. Okay, so we want to find what is this shift down. Okay, so just by looking at this picture, we can see what the shift is. It's the distance between the parabola and the straight line, that vertical distance. Okay, so what happens if you didn't know that? What could you do instead? Well, if you didn't see this little picture here, what you could do instead is take the shifted parabola, make it equal to the line to find this point of intersection, that intersection point there, and then any k value after that, there's no intersection. Okay, so there's two ways to do it. You could either just find the vertical distance, or you could do it the slightly longer way. Okay, let's do it the longer way just to see what it's like. So 5.7. So we're going to solve for one intersection. Okay, so we're going to have our p of x is equal to g of x, and that's how we can determine our value k. So we're going to have minus 2x squared plus 4x plus 16, and then we've shifted by k, so plus k, and this is equal to 2x plus 4. Okay, so it's pretty messy. Let's take everything over to one side. So we're going to get minus 2x squared plus 4 minus 2, so plus 2, and then 16 minus 4, that's going to be 12. And then we still have our k. Okay, good. The solutions to this will give you the intersection points. So no intersection, one intersection, or two. And how do we tell how many solutions we've got? We use is the discriminant, the triangle. So that's going, what we want is just one solution. So this needs to be equal to 0. Okay, so a bit of substitution. B is 2, so we're going to have 2 squared minus 4. A is minus 2. And C is this collection of 12 plus K. And that's equal to 0. Okay, so we're going to have 4 plus 8. 12 plus K is equal to 0. We can divide through by 4 just to make things a bit easier. So 1 plus 2. 12 plus K is equal to 0. So 1 plus 24 plus 2K is equal to 0. 2K is going to be minus 25. So K is going to be minus 25 over 2. Okay, that's how much we had to shift down, which makes sense. K is negative. And remember what we wanted? We wanted to shift it down. So of course, K has to be negative. Now this K value gives us where it is just touching. So anything after this K value, there is then no intersection. So keep in mind, at this point, there is one intersection. After this point, there is no intersection. So we want K to be less than minus 25 over 2. Okay, and this is a strict less than, not equal to. So just to emphasize, not equal. Okay, because remember, if it is equal, then we have one intersection. We want no intersection at all. So it has to be much smaller than this. Okay, or in other words, more negative, a larger shift down. Okay, a larger shift down, more negative. Okay, however you want to think about that.
Hi, sorry, you broke up during the explanation.
No, okay. Where did I last leave? Okay, how about this point over here? Was all of that all right? Let's get a thumbs up. Okay, when I made the two functions equal, was that still all right?
I think maybe just do a quick recap of everything you did.
Okay, so scroll back up here. So we've got this parabola F, and we are shifting it by this amount K. Okay, so we're shifting it either up or down depending on K. What we want is to have no intersection between this parabola and the straight line G. Okay, I've highlighted that in green. So what we need to do is take the parabola and shift it down. Okay, so this is a shift down. At some point, the parabola and the straight line are going to intersect at only one point. This point here. Okay, so how can we find that point? Well, we've got two functions. We want to find the intersection, so we make them equal. So we're going to take P, which is our shifted parabola, and make it equal to G. Okay, so we do that over here. So this is taking the shifted parabola and making it equal to the straight line. That's going to give us our intersection points. So we make it equal, we get ourselves the quadratic equation. The roots or the solutions of this quadratic equation give us the intersection points. Okay, now remember your nature of roots and the discriminant. If the discriminant is equal to 0, then we only have one intersection point, which is what we were looking for. So discriminant equal to 0, one intersection point. Okay, which is what we want, is we want to find that distance k. So we find the discriminant, we substitute b, we substitute a and c, do our calculations to solve for k, and we get k is equal to minus 25 over 2. Okay, so it's good that it's negative, because remember, we wanted to shift down. Okay, so that's why we've got a negative answer there. Now, at this point, there is one intersection. Below this point, there's going to be no intersection. So we take k being less than this value. Okay, so k less than minus 25 over 2. There is no intersection anymore. Okay. So for any k value smaller than this, there is going to be no intersection between the parabola and the straight line. Okay, I hope that's all right. If you do have any questions on that, please just put them in the chat. Okay, let's take a look at the next one. Okay, so we've got an exponential now. So we've got g of x is equal to 3 to the x, okay, exponential there. Write down the equation of g inverse in the form y equals something. Okay, so we're going to do very similar thing as before. So for 6.1.1, we start off with g. That's going to be 3 to the x. We write this as y is equal to 3 to the x. Now we want to find the inverse, so we do the x and y swap. So x is equal to 3 to the y. Sorry, that's a y. So x and y have been swapped. Now we need to solve for y. Since y is in the exponent, we're going to have to use logarithms to get it back down. Since the base is 3, we're going to use log base 3. So log base 3 of x is equal to log base 3 of 3 to the y. Okay, so now we just use our log laws. So this exponent is going to come out to the front. So we have log base 3 of x is equal to y times log base 3 of 3. And it's a good thing we chose log base 3, because log base 3 of 3 is just going to be 1. So we have y is equal to log base 3 of x. Okay, so this is our g inverse. Okay, but they wanted it as y equals something, so we can just leave it like that. Okay, 6.1.2, we've got point P, which is 6 and 11, lies on H, which looks like G, but translated a bit. So let's just make a little note of that. So H of x is G of x, but translated. We see that there is a shift in x. We've moved 4 units to the right. And we see this plus 2, so that's 2 units up. Okay, so that is the translation that we've done on G to arrive at H. Okay, let's write down the coordinates of the image of P on G. Okay, so this P is on H. We want to find the image on G. So P, which was 6 and 11, lies on H. We want to find P prime, which is the image on G. In other words, after the shift, we arrived at 611. What happened before the shift? So P prime is going to be 6 minus 4, 11 minus 2. So P prime is going to be given by 2, 9. We just have to undo that shift that we did. Okay, and then that is the image. We denote that with a little prime. Okay, so whenever you see a little prime above a point, we mean the image of the point. Okay, that's not too bad. If you do have any questions, please just let us know in the chat. Let's have a look at the next one. Okay, more exponentials. So we've got this exponential 2 to the x plus p. So we've got a horizontal shift by p, and we've got a vertical shift by q. Okay, so just to keep that in mind. So we've got a point on the curve at 316, and we've got an asymptote at minus 16. So this is our asymptote to the exponential. Okay, so we can use this information to find out what P and Q are. Okay, so firstly, Q is going to be just minus 16. Because remember, the original asymptote would have been at 0. Okay, but the new asymptote is at minus 16. So we've shifted down by minus 16. Okay, what about P? It's a bit more complicated. However, we do have a point on the curve. So we can use that to find the missing value. So we know f of x is equal to 2 to the x plus p. We don't know what p is just yet. Plus q, we know what that is now. That's minus 16. What we can do is substitute the point t. Okay, because it lies on the curve, it satisfies the equation. So we're going to have 16 is equal to 2 to the x, but x is 3, plus p minus 16. So this will allow us to solve for p. We can take the 16 across to the other side. So we're going to get 32 is equal to 2 to the 3 plus p. Now on the right-hand side, we have this as base 2. On the left-hand side, we've got ourselves a 32. What we can do is write the 32 using a base of 2. Now, since the bases on either side will be the same, we can then compare the exponents. Now, 32, that's just going to be 2 to the 5. Okay, so easy way to remember that. 2 to the 4 would be 16, and then you just double up every time. So 2 to the 5 will then be 32. And this is equal to 2 to the 3 plus p. Now, these bases are the same, which allows us to then compare the exponents. In other words, 5 is equal to 3 plus p. Of course, you could have also taken log base 2 on both sides. Yeah, that would have accomplished the same thing. Or you just notice the bases are the same. You can compare the exponents. Okay, so 5 is equal to 3 plus p. So p must then be 2. Okay, so we've got q and we've got p. Okay, are there any questions on this? Okay, let me just check the chat real quick. Okay, nothing there. Cool. Let's have a look at the next thing. Okay, so we moved away from exponentials. Now we're looking at some log plots. So we've got the graph of f, which is log base 4 over 3. Okay, it's a weird base, but we can work with that. So log base 4 over 3 of x, and we've got this point b. Okay, so b, that's the point on the curve. However, we don't know what p is. So let's just make a little note there. We don't know p. Okay, so we can't substitute that point to do anything yet. 4.1, for which values of x is log base 4 over 3x less than or equal to 0? Okay, that's pretty straightforward. This is going to be between 0 and 1. Okay, 4.2, determine the value of p without the use of a calculator. Okay, so let's just look at that. So without the use of the calculator, so there must be some method to find that. Okay, so let's go ahead with that. P is the y part of the point B. Okay, so B is given by 16 over 9, and the y part is P. We don't know what that is. So if y is equal to log base 4 over 3 of x, okay, the y part in this case is P. We don't know that. And then we have log base 4 over 3, and x is 16 over 9. Now, I hope you see this relationship between this 4 over 3 and 16 over 9. 16 over 9 is just 4 over 3, but we've squared it. So P is equal to log base 4 over 3. And then inside here, we've got 4 over 3 squared. Okay, now we can use our log laws, because this 2 can come down to the front, and we're left with P is equal to 2 log base 4 over 3 of 4 over 3. Okay, now again, it's a weird base, but that doesn't matter. As long as this is the same as this, then the log is going to give us 1. So P is equal to 2. Okay, so not too bad. You just needed to see that the argument of the log is the base squared. Okay, so we can write it as the base squared, and then of course we can use our log laws to take that exponent down. Okay, and then log base of the base, that's always going to be 1. Okay, 4.3, write down the equation of the inverse of f in the form y equals something. Okay, so 4.3. Let's start off with the original. So y is equal to log base 4 over 3 of x. Okay, now we're going to do the little switch between x and y. So x is equal to log base 4 over 3 of y. So we have done a little swap of x and y. So what we want to do now is solve for y. Okay, because once we've solved for y, we've got the inverse. Now, this base is 4 over 3. So the way that we can get rid of the log is to make the base on both sides 4 over 3. And then on the right, we raise it to the power x. On the left, we raise it to the power x. On the right, we raise it to the power log base 4 over 3 of y. So on the left, we have 4 over 3 to the x. On the right, we have 4 over 3 to the log base 4 over 3 of y. Now, exponentiation and logarithms, those are inverses of each other. In other words, if we take one and compose it with the other, in either order, they cancel. So in this case, the exponential, the 4 over 3, and the log, base 4 over 3, they're going to cancel each other out. So we're just left with 4 over 3 to the x is equal to y. And this is our F inverse. Okay, now they don't want us to write it as F inverse, but I'm just making a little note so that we know for later. Okay, 4.4, write down the range, so that's your y values of F inverse. Okay, so 4.4. The range of F inverse. Well, it's an exponential. So notice that F inverse is an exponential. Okay, and it's going to look something like this. Something like that. Now, this is strictly positive. Okay, it never touches the x-axis. It never goes below the x-axis. So the range is everything above the x-axis. So we can say y is greater than 0, strictly greater than 0, it doesn't touch the x-axis. Or we can say from 0 to infinity, if you want to write it as a set, you can say y is an element from 0 to infinity. Okay, anything like that. Okay, as long as we have only positive values of y not being 0. Okay, I don't see any questions in the chat, so everything's pretty good so far. Okay, any questions before we move on? Okay, awesome. Okay, last bit of work, and then we will take a short break and then go on to the finance. So we've got ourselves a parabola G. So let's put that in yellow. Oops, sorry. Parabola G and a hyperbola F. So let's put that in blue. Okay, so we can see what we're working with. C is the turning point of G, so that's the top of our parabola, and it lies on the horizontal asymptote of F. Okay, so that's going to be useful. The graph of G passes through the origin, okay, and we've got the point B that lies on the hyperbola. Okay, so that's everything that's given to us. 5.1, write down the domain of F. Okay, so for 5.1, we're given that f of x is equal to 2 over x plus 1 plus 4. Now, this f can take any x value except when the denominator becomes 0. Then we have a problem. When the denominator is 0, this function is going to blow up to plus and minus infinity. So that point cannot be in the domain. So when x plus 1 is equal to 0, we get x is equal to minus 1. This point that cannot be in the domain. We need to remove it. In other words, the domain is given by x being any real number, but not -1. We can't have that. Okay, you can write it like that, or we could write it as a set. We could say from -infinity to -1, union -1 to infinity. And we've got these round brackets to show that we are not including -1. Okay, that's not part of our domain. Okay, 5.2, determine the x-intercept of f. Okay, so 5.2, x-intercept. Well, that means we're letting y be equal to 0. So 0 is equal to 2 over x plus 1 plus 4. We just need to solve for x. So we're going to have -4 is equal to 2 over x plus 1. -2 is equal to 1 over x plus 1. We can just flip this around. We get -1/2 is equal to x plus 1. So x is equal to -3 over 2. So altogether, we have -3 over 2, and the y part is 0. Okay, since it's an x-intercept. Okay, so that's not too bad. 5.3, calculate the value of k. Okay, so what was k? K was the x part of point B. So B lies on F, so it satisfies the F equation. We can use that to find k. So 5.3, we know that B satisfies the F equation, so it's going to be 14 over 3. That was the y part, or the f of x part, if you want to think of it like that, is equal to 2 over x plus 1 plus 4. And here, this x, that's going to be our k value, because that's the k part of the coordinates. Okay, so we can solve now. So we're going to get 14 over 3 minus 4 is equal to 2 over x plus 1. Okay, so we have 14 over 3 minus, we can write this as 12 over 3 is equal to 2 over x plus 1. So we get 2 over 3 is equal to 2 over x plus 1. So x must be 2. And since this is the x part of B, we know that k must be 2. Okay, so I don't think that one's too bad. Okay, however, if you do have any questions, please don't hesitate to ask in the chat. Okay, 5.4, determine, 5.4, write down the coordinates of C. Okay, so what was C? C is the turning point of our parabola. Now we know that the parabola touches the asymptote. So whatever the y value of the asymptote, okay, so let's just make notes of that. Okay, so the y part of C is equal to the horizontal asymptote. Okay. Okay, and what about the x part of C? Well, if we go check here, we see that B and C are vertically aligned. They share the same x value. So the x value of B, in this case k, is the same as the x value of C. So that's also k. But we know what k is. K is 2. Therefore, C is given by 2, 4. Okay, the 2 came from the x part of B, and the 4 came from the horizontal asymptote of F. Okay, 5.5. Determine the equation of G in the form y equals a x plus p squared plus q. So the turning point form. Okay, that's really easy because we know the turning point. So we can just substitute in what we know. So 5.5. We want G in the form a x plus p, all of that squared, plus q. But we know p and q because that's just our turning point, which is c. So g of x is equal to a x minus 2 squared plus 4. However, we don't know what a is. That's still an unknown. However, we do know another point on the curve, the origin. Okay, so the origin there, that is another point on the curve. We can use that to solve for a. So let's substitute that in. So we substitute 0, 0, and we can use that to find a. So we're going to have 0 is equal to a, still don't know what that is, 0 minus 2 squared plus 4. So 0 is equal to 4a plus 4. We can take that across, so minus 4 is equal to 4a, a is equal to minus 1. Which makes sense because if we look back at our picture, we've got ourselves a sad-faced parabola. So we expect that a to be negative. If a was positive, then we would have done something wrong. Okay, because then that would mean it was a happy-faced parabola. Okay, so these quick checks that you can do, very quick just to check, you know, do I have a sad-faced parabola, happy-faced parabola? It can save you a lot of time later on when you have to check your work and then try to figure out where did things go wrong. Okay, so, you know, just while you're going through these questions, do these little checks. So in this case, A was negative, that makes sense. Okay. So let's look at 5.6. We've got, for which values of x will f of x over g of x be less than or equal to 0? Okay, now in this case, we want the ratio or the fraction to be negative or 0. Now that can only happen if f and g have opposite signs. Because if f and g were both positive, then we would get a positive number. If they were both negative, we would get a positive number again. If they are opposite signs, we get ourselves a negative number. So what we're looking for is where one graph is above the x-axis and the other one is below the x-axis. So let's have a look. Now we come in from minus infinity and we reach this point over here. For that whole green part, okay, from minus infinity to the x-intercept, we see that f is above the axis and g is below the axis, which means the ratio must be negative. If we look at this portion over here, okay, not including the asymptotes, of course, we see that f is above the x-axis and g is below the x-axis. So that's good. In the next portion, from the origin to the x-intercept, we see that both of them are positive. So that's no good. If we look after the second intercept, so from this intercept onwards, we see that f is above the x-axis and g is below the x-axis. So again, the ratio would be negative. So we've got 1, 2, 3 regions in which the ratio would be negative. So all we need to do is take the union of all 3 and we've got ourselves the interval. So for 5.6. X is an element of minus infinity. And remember, it stopped at the X-intercept. That was at minus 3/2. Okay, union. The next bit was from the asymptote to the origin. But remember, we can't include the asymptote. So it's from -1 to 0, not including -1. So -1 to 0, not including -1. Now, a question you should ask yourself is, can we include 0? Well, at 0, G is going to be 0. And if we look back at our ratio, G is in the denominator. We can't have that, can't divide by 0. So in fact, we cannot include 0. This needs to be a round bracket. And lastly, this bit after the second intercept, we want that to be included as well. Okay, so that's going to be from 4 to infinity. And again, we cannot include that point because if we did, we would be dividing by 0. We can't do that. So it's from 4 onwards, not including 4. Okay, so that gives us our possible X values. Okay, so it's 6 o'clock now. Let's have a short break for 5 minutes, and then we can move on to the finance. Okay, so you can go grab something to eat, get some coffee or tea, and then we'll meet back at 6:05. And then we'll take a look at all of the finance stuff.
One's success can be attributed to those thereof shoulders with. Therefore, you must surround yourself with like-minded people. So, how do you become part of a community that is committed to your self-development? How do you become part of UKZN? First, you have to apply. All applications for undergraduate studies at UKZN are processed through the Central Applications Office, CAO. This is for both your course and student resident applications. The application process is as follows. Step 1. Consult the CAO handbook. This handbook provides a list of all qualifications available at UKZN. Through the various courses offered and choose a program that interests you and for which you meet the minimum requirements. As one of the top 5 universities in the country, UKZN promotes academic excellence. So meeting the minimum requirements does not guarantee you a place to study. Step 3. Find the program code linked to your chosen qualification. This is the code you need to enter in your application form. Okay, let me show you something. You see, a code has 3 parts. Example, for BCom in accounting, the code is KN-P-BCN or KN-W-BCN. Crazy code, right? Well, basically, the KN stands for UKZN, the middle part stands for the campus of your choice, P for Pietermaritzburg, W for Westport. Then BCN stands for the actual course. Make sure to get these codes right. Step 4. Use this program code when completing your CAO form, which is available from the CAO website. Your application will be sent to UKZN. You can always check the status of your application using your CAO number, ID number, or passport number on this website, www.caocheck.ukzn.ac.za. For more information, visit www.cao.ac.za. It's that easy. Pay close attention to closing dates for qualifications. For example, MDCHV closes on the 30th of June, whilst other undergraduate programs close on the 30th of September. What are you waiting for? Apply now and shape your future today.
Hello again. I think we should just wait for one more minute. I think people were joining back. Okay, so we'll just wait a little bit for those people to join back, and then we'll move on to the finance part. Okay, so if you still have questions on functions, please post them in the chat, and then we can have people look at that, or you can use the dedicated email line if you have questions later on. I've got a question here. Is this covering Matric work? Yes. Yeah. So all of this is Matric pure maths. Okay, so let's move on to the finance section. Okay, so finance is not too difficult. It can get a bit tricky at some points. You need to know about payments and how many payments and all of that. But as long as you know how to use these formulae, then there shouldn't be any problems. Okay, so let's start. Okay, so we've got this car worth 180,000. Okay. The value of the car depreciates. Okay, so that means the value is going down. 15% per annum. Okay, according to the reducing balance method. So there's that equation we need to know for that. Okay, and we've got the book value. Okay, so when they say book value, they mean like the current price after the depreciation. Okay, it's whatever you keep track in your accounting books. Okay, so we know all the years are. Sorry about that. Got cut off for a minute. Let's put that back. Okay. Yeah, so we've got this reducing balance formula. We know that A is going to be this book value. So that's going to be 79866,96 is equal to P, that's our starting off value. That's 180,000. 1 minus R. So we've got the interest rate. That's 15% per annum. We can write that as 0.15 as a decimal to the power n. And that's what we want to find. We want to know what n is. So let's divide through by this 180,000. So we're going to have 79866,96 divided by 180,000 is equal to 1 minus 0.15 to the power n. Okay, so now we want to solve for n, and n is in the exponent. So let's just highlight that again. It's in the exponent. How do we get the exponents down? Well, we need to take the log on both sides. So we can take the log of 79866,96 over 180,000, and that's equal to when we take the log, the n is going to come down. So it's going to be n log 1 minus 0.15. So n is going to be equal to 0.96 over 180,000, all divided by the log of 1 minus 0.15. Okay, so please keep everything together right to the end. So you don't want to be rounding off at each step. You save that for the very end. 5 years. Okay, so that's how long this car has been depreciating for. Okay, 6.1.2. We've got this other person here, and they're depositing into a savings account. Okay, oops, sorry. 49,000 into a savings account, interest rate 10% per annum, compounded quarterly. So we need to keep that in mind. That's going to affect the interest. We want to know if they have saved enough money to afford the car. Okay. So 6.1.2. Sorry, 6.1.2. Okay, so the savings account is going to have compounded interest. So it's going to be A is equal to P, 1 plus R to the N. Okay, normal compound. So A is equal to, the starting amount is 49,000. That was the initial payment there. 1 plus, the interest was 10%. We can write that as 0.1. It was compounded quarterly, so we have to divide that by 4. And then what is N? Well, we see here that it was going for how many years? 5 years. And it's compounded quarterly, so N is going to be 4 times 5. Yeah, so for 5 years, and it's every quarter that this gets compounded. So altogether, it's 4 times 5. Okay, so that means A is going to be equal to 80,292,21, which is good because that is larger than this book value price, okay, which was 79,000 and so on. So yes, they can afford the car. Okay, with some change. Okay, are there any questions about this so far? Okay, so not too bad. Let's have a look at the next one. So exactly 10 months ago, okay, so keep that in mind here. So 10 months ago, this person got a loan of 800,000. So this is the loan value at an interest rate of 10.25% per annum, compounded monthly. Okay, so please keep that in mind. This compounding is happening every month. Okay, so every year it happens 12 times a year. Okay, so the loan must be repaid over 20 years. So that's the total lifetime of the loan. And the monthly repayments are this much, starting 1 month after the loan was granted. Okay, so you get that first month with no repayments. 6.2.1. How much did Jane owe immediately after her 6th payment? Immediately after. Okay, and she's already made 6 payments so far. So let's keep that in mind. So 6.2.1. So we're going to have P is equal to X, which is our payment amount, 1 minus 1 plus R, because it's being compounded to the minus N, all over R. Okay, so that is the formula we use for repayments or payments. And we know all the values, we can work that out. So P is equal to X, that's our payment amount. That was 7853,15, 1 minus 1 plus R. It was 10.25%. We can write that as 0.1025. Compounded monthly, so we need to divide this by 12. And then what do we put for the exponent? Well, it was 20 years, compounded monthly, so that's 20 times 12 payments. They already made 6, so it's going to be minus 234. So just in case we don't know where that comes from, that's from the 20 years times the 12 payments, or the 12 compounds per month, minus 6, because they've paid 6 already. Okay, and all of this is divided by R. Again, we can write that as 0.1025. Remember, it's compounded monthly, so we need to divide this by 12. Okay, so after all of that substitution is done, we see that the amount that is owed immediately after is going to be 749.25. So this is the amount owed, including all the interest and such, after 6 payments. Okay, so that's the 6 that appears over here. Okay, so not too bad. As long as you can figure out all of the individual elements, you just put all of them into the formula, and then you can get your answer. Okay, 6.2.2. Due to financial difficulties, Jane missed the 7th, 8th, and 9th payments. Okay, so that's not good. In other words, 3 payments have been missed. So she paid the 6th one, the next 3, so they're all consecutive, they've been missed. She was able to make payments from the end of the 10th month. So 7, 8, and 9 were missed, but 10 onwards, everything was fine. Calculate Jane's increased monthly payments in order to settle the loan in the original 20 years. So because she missed the 3 payments, we need to recalculate the monthly payment such that the total amount is still paid over the original 20 years. So we need to take these 3 into account. Okay, so let's do that. 6.2.2. So we have A is equal to P, 1 plus R to the N. Okay, compounded, of course. Now, the payment going into this was 793,749.25. Remember, that was after the 6 months. Sorry, not 6 months, the 6 payments. Then it gets compounded for the 3 payments that were missed. So we have 1 plus 0.1025 over 12, of course, compounded monthly. Now to the power 3. This is for the 7th, 8th, and 9th missed payments. Okay, so the amount of interest being paid, that still goes over the 3 months, even if you're not paying. Okay, so we need to compound that for the 3 months that were missed. Okay, so the loan amount goes up because you're not paying back. Okay, so this is going to be 814,263 comma 3052. Let's leave the decimal places for now because we've got more work to do. Notice how it's gone up. It was 793,000. Now it's 800,000. Okay, because of the missed payments. Now we need to find the new payments. Okay, so how do we do that? Well, same formula. P is equal to X. We want X, that's our monthly payment. 1 minus 1 plus R to the minus N. All over R, okay, same as we used before. Okay, now we want to find X. So the total amount that we need to pay, or that she needs to pay, is 814,263,3052. So I just kept the decimal places because we've got all this extra work here. Okay, and that's equal to X. We want to know what that is. That's our monthly payment. So it's going to be 1 minus 1 plus the interest, same interest, 10.25%. Compounded monthly, we divide by 12. Now it's to the minus 231. Where did we get that number from? This is from the fact that it is 20 years, 12 months per year, minus 9. Okay, because we've already dealt with those 9 payments. So the 9 leftover payments from here. Okay, so you can see from the 10th month, you're paying from there. So we need to subtract the 9. Okay, so we want to solve for X. So we just take, divided by 0.1025 over 12. Okay, now we can take all of this over to the other side. And then we can solve for X. And X is going to be 8089,20. So this is the new monthly repayment. And just a quick little check. This is 8,000. What was the original? The original was 7,000 and something. So that's expected. We expect the payment amount to go up a little bit. Okay, so from 7 to now about 8. If the payment amount went down, then we've done something wrong. We need to go back and check. Okay, but this seems logical. It's a not so much improvements from what was being paid originally. Okay, so we can be confident in this. Okay, so that's everything for this part. Any questions so far? Okay, so not too bad. Just remember that this N value over here, you need to be a bit careful with that because that N could be number of years if you're making yearly payments, or it could be over months if you're doing monthly payments, and so on. So you need to keep track of how many payments you're making. It's not necessarily how many months they've been or how many years there's been. It's per payment. Okay, so you need to keep track of it like that. Okay, just in this case, it was 12 payments per year because it was monthly payment. Okay, let's have a look at the next one here. So here we go. 7.1. We have an amount of 10,000. Okay, was invested for 4 years. Okay, so we know how many years. Earning an interest rate at R. Okay, we don't know what that is. Per annum, compounded quarterly. So as soon as you see compounded quarterly, we know we need to do that dividing by 4. Okay, so at the end of 4 years, the total amount in the account was this much. Okay, so that was the initial amount plus all the interest earned. Determine the value of R. Okay, so let's do that. Okay, so 7.1. So we know the final amount was 13,080. The initial amount was 10,000. Okay, it's in a savings account, so we've got that compounded interest going. So it's 1 plus I. We don't know what that is, so we leave it as I. It's compounded quarterly, so we have to divide by 4 to the power of n. Now remember, this is being compounded quarterly for 4 years. So how many times is it actually being compounded? It's going to be 4 times 4, so 16. So this is number of times this gets compounded. Okay, so again, not necessarily years. It depends on how the interest is actually added. Okay, so if it's compounded quarterly, it's going to be 4 times per year. If it's compounded monthly, it will be 12 times and so on. Okay, so we've got this. What we want is R. That's the unknown here. So we can solve for that. It's not too bad. 13,080 divided by 10,000 is equal to 1 plus I over 4 to the 16. Now we want to get rid of that 16. So let's raise both sides to the power of 1 over 16. So we end up with 1 plus I over 4 is equal to 13,080 over 10,000 to the 1 over 16. We could have also written this as the 16th root. Okay, you could also write it like that, the little 16 in the corner there. However, I would avoid this because this looks a lot like multiplication. Yeah. However, if it's an exponent, you know exactly what that means. Okay, so maybe avoid this radical way of writing it. Okay, so we don't want any unnecessary errors there. Okay, so we need to take the 1 across. So we get I over 4 is equal to 13,080 over 10,000 to the 1 over 16, and then we took the 1 across. Then lastly, we need to multiply by 4. So we have I is equal to 4 times 13,080 over 10,000 to the 1 over 16 minus 1. And notice I didn't do any calculator work along the way. We save all of the rounding off for the very end. So if you do rounding as you go through, your answer might be way off from what it should be, just because of all the rounding errors you're carrying through. So please keep, so save the answer right to the end where you put everything into your calculator at once. Okay, so save your calculator for the very end. Okay, so you could be doing all the steps right, but it's just those rounding errors that can add up. Okay, so we put this in and we get I is equal to 0.06769. Nice. So I is equal to 6.77%. Okay, so that's our interest rate. Well, they asked for R, so I guess we should write R is equal to 6.77%. Okay, but that's the same thing. Interest rates are, or the interest rate R, that's the same. Okay, any questions on this so far? Okay, so it's just a handful of formulae and you just need to know what goes where. Yeah, it's not too bad. Okay, let's look at part 2. So we've got an initial deposit of 9,000 Okay, at the end of January, all right. Okay, monthly deposits of 9,000. So every month we're making a payment. So we know what formula to use in that case. At the end of each month up to the end of December 2018. Okay, so that's the number of years there. So from 2014 to 2018, they've made these monthly payments or monthly deposits of 9,000. Okay, good. The account earned interest at a rate of 7.5%. So that's our R. Compounded monthly, we need to divide by 12. Okay, so as you're reading these questions, just say to yourself, you know, what do I need to do? So as soon as you see compounded monthly, you say to yourself, okay, I need to remember, divide the interest by 12. Okay. Okay, just so you don't forget later on. All right, 7.2.1. Calculate how much money was in the account immediately after 60 deposits. Okay, so immediately after, so we're not including that month's compounding, okay, because that happens at the end. 60 deposits. In other words, 60 payments. After 60 payments, how much is there? Okay, so we know how to work that out. 7.2.1. That's going to be this formula with the F is equal to X. That's our monthly payment of 1 plus R to the N minus 1 all over R. Okay, so we've seen that before. So F is going to be equal to X. That was 9,000. That was the monthly payments or the monthly deposits. 1 plus I, what was that again? 7.5% per annum, compounded monthly. Okay, so we can write that as a decimal as 0.075. Compounded monthly, we said we had to divide by 12. N, that's the number of payments. The question said immediately after 60 payments. So that's a 60. And then the minus 1. All over R, so that was 0.075. And it's compounded monthly, so again, we divide by 12. Okay, so we've put in everything we need, and we save the calculator work for right at the end, and we get our F is equal to 652,743,95. Okay, nice amount of money there. Okay, so that is immediately after the 60th payment. So just to emphasize that, N was 60. Okay, any questions on that? Okay. Then there's this next part. So this amount was left in the account for a further N months. Okay, we don't know what that is. So it was just left for N months afterwards. The interest rate remained unchanged. So still 7.5% per annum, compounded monthly. Remember, divide by 12. Okay, no further payments were made. So the account was just left. So after that, we just left it alone at the interest rate that was set. Okay, the total interest earned over the entire investment period was this much. Now, this is not the amount in the account, this is the interest. Okay, so this is the added on value. Okay, so we're not including what was there to begin with. Okay, determine the value of N. Okay, so N is how many months did this person leave the account as is. Okay, so we know the interest amounts earned, so we can work backwards to find what N should have been. Okay, so 7.2.2. Okay, so how do we go about doing that? Well, how many total payments were made? That would have been 60 payments of 9,000 Rand. So that was 540,000. That's how much is in the bank account without any interest. That's just from this lady putting in money on her own. Okay, so no interest here. Okay, you can think of this as like the base amount before we add the interest on top. Okay, so A is equal to P, 1 plus R to the N, again, compounded because it's a savings account. A, we know what that is. We just worked that out before. That was 652,743,95. Sorry, oh, not equals yet. Bracket 1 plus R. So we know what I is. We can put that in. So 1 plus 0.075 over 12 to the N. We don't know how much that is. So this was the amount just left in the account. So that's what we're starting off with. It's just left there for N months. And while it's sitting there, it's earning compounded interest. So we need to add on that extra part. So what does this equal? Well, it's going to be equal to the interest earned, which the question says was 190,214,14. Now that's only interest. That's not including all the money that this lady put in every month. So we need to add that on. So that's the 540,000 from all those monthly payments. So this splits up into two parts. This is only interest. And this is from monthly payments. Okay, if we add all that up, we get the total amount that's actually in the account. Okay, cool. We're still looking for N. We don't know what that is. So let's add up the right-hand side and solve for N. So we're going to have 730,214,14. That's adding up the right-hand side is equal to 652,743,95. This was the amount in the account before she left it. Then it gained interest, so 0.075 over 12. To the N, we still don't know what N is. So let's highlight that. We still want to find that. Okay, so N is in the exponent. So we need to use our logs again to get it down. So we're going to have 730,214,14 divided by 652,743,95 is equal to 1 plus 0.075 over 12 to the N. And again, I'm not dividing this. I'm not putting the answer down yet. You save that for the very end. Okay, so now we want to take the N down. So we need to use our log rules. So we take the log on both sides. Okay, divided by 652,743,95 is equal to, now we take the log, the N comes down because of the log laws. And then we have the log of 1 plus 0.075 over 12. Okay, and we still got this N. We still want to try to find that. So finally, N is equal to the log of 730,214,14 divided by 652,743,95. And all of this now is divided by that other log, 1 plus 0.075 over 12. Okay, now we can put all of this into our calculator. and we end up with 18 months. Okay, so you're going to get some 18 with fractional parts. However, if you want to know the number of months, then we need to put the answer down as an integer. Okay, so if it's something like, okay, that's going to be 18, or if it's 18.2, so I don't want to work with fractional months. Okay, any questions on this one? Okay. Okay, so I think that's it for this one here. Last one for today. Calculate how many years it will take for the value of a truck to decrease to 50% or half its original value. Okay, so we want the book value to be half. If depreciation is calculated at 15% per annum using the reducing balance method. So the amount is going down exponentially. Okay, because we've got that n in the exponent. Okay, so how long? So 6.1. So we have a is equal to p, 1 minus r, because the value is going down, to the n, because it is reducing balance, it's compounded. We want a, the book value, to be half of the original one. So it's going to be half of p. And we start off with p. 1 minus 15% per annum, we can put that as 0.15 to the n. And again, we don't know what n is. We want to find that. Okay, we got p's on both sides. We can get rid of those. Okay, and we can use the log laws to get that n down from the exponent. So log of 1/2 is equal to n log of 1 minus 0.15. Okay, no simplifying yet. We save it for the end. So n is equal to log of 1/2 divided by log of 1 minus 0.15. Okay, take the ratio of the logs and we get approximately 4.27 years. Okay, so almost 4 1/3. Okay, almost there. Okay, so that's how many years it will take to reach half of its original value. Okay, 6.2. Okay, so we've got a monthly deposit of 1,500, interest rate 9.2%, compounded monthly. Okay, so the first payment is when they're 23. Last payment is when they're 55. So if we take 55 minus 23, that's going to be the number of years. Okay. Okay, so we've got everything there. Calculate how much money he had in the account on his 55th birthday. So from 23 to 55, over those many years, what's the new balance? Okay, so 6.2. F is equal to X, that is our monthly payment. 1 plus R to the N, how many payments? Minus 1, all over R. Okay, so we've seen this a few times now. Okay, so the monthly payment was 1,500. 1 plus, the interest was 0.092 as a decimal. Compounded monthly, we need to divide by 12. How many payments? Well, it was 55 minus 23. That's the number of years times 12. So we're going to get 384. So this was 55 minus 23 times 12. Minus 1. All over the interest 0.092 as a decimal over 12. Okay, so we've substituted everything we needed. We can put this in our calculator and we get a large amount of money, 3,478,620,49. Okay, that is a nice retirement amount there. Okay, so again, it's the same thing that we saw before. You're making monthly payments of X. You make the payments for so many payments. You've got your interest rates. You can work out the total amount that you've got at the end. Okay. However, this is not it. Okay, because if we take a look here, whoops. 1 month before, that was the last payment. So in fact, this extra month now is getting interest. Okay, because they made the payment 1 month before. During that month, it's going to be gaining interest. So we need to add that on. Okay, so a little note. Add the last month of interest gained. Okay, because it's sitting there for that last month, it is gaining interest for that amount of time. Okay, so that's going to be A is equal to the amount that was there before the month. So that was this large number, 3,478,620,49. 1 plus same interest rate, 0.092 over 12. But now it's just sitting in the account for that 1 extra month. So N is 1. So now the final amount on the birthday, so after this month, is going to be Rand 3,505. Okay, it's gone up quite a bit there. 289,91. Okay, so please check your questions for those sneaky months. So sometimes there's an extra month, sometimes there's 1 month less. You do need to read the questions carefully. In this case, there was this extra month, well, not really an extra month, but the last month where it gains interest. Okay, up to the 55th birthday. Okay, so we do need to add that on. Okay. Okay, last question for today. We've got an investment of 150,000 in 2 separate accounts. So this money is split between 2 investments. One account pays an interest rate of, let's do it in 2 different colors so we're not confused. So we got 8.4% per annum compounded quarterly. Okay, so compounded quarterly, we need to divide by 4. And the other account is at a rate of 9.6% per annum compounded monthly. Okay, so if it's compounded monthly, we need to divide by 12. How much money should be invested in each account so that he will collect the same amount from each account at the end of 12 years? Okay, so the 12 years is important here. Okay, so we've got an amount A put into account A. We've got an amount B put into account B. We want to work out those values such that they are the same. Okay, so that's not too bad. Let's have a look. Okay, so this is 6.3. Let's A. Okay, so this A is different from the A in the formula here. So this is just like A and B variables. So let A be the amount invested at, the first one was 8.4% per annum compounded quarterly. Okay. Let B be the amount invested at, that other one was 9.6% per annum. This was compounded monthly, so they work differently. Okay, so we know what goes where now. We know that the total amount, A plus B, needs to be that 150,000 that he started off with. So some of it goes to A, some of it goes to B. We need to work out what that is. Okay, so we can use this to solve for A. So that's going to be 150,000 minus B. Okay, so now we can just work with A like that. Now we want both accounts to produce the same amount. So let's look at the A account. That's going to be 150,000 minus B. It's going to be 1 plus 0.084 as a decimal, compounded quarterly to the, it was 12, the number of years, compounded quarterly. So 4 times 12, that's going to be 48. You can think of it as 48 compoundings as it goes through. This is equal to the amount in the other account. So that was B. 1 plus 0.096 different interest. That was compounded monthly. And that was for 12 years again. But this is compounded monthly. So it's going to be 12 times 12. So 144 compoundings, if you want to think of it like that. Okay, so we've got this B variable over here. We want to work that out. Okay, so we are going to get 150,000 times 1 plus 0.084 over 4 to the 48. So I'm just distributing the left-hand side there. Minus B times 1 plus 0.084 over 4 to the 48. And then on the right-hand side, we can just leave that alone. 1 plus 0.096 over 12 to the 144. And let me just highlight this B again. We're still trying to look for that. Okay, so we can take all the B terms to one side so that we can then solve for it. So we're going to have B into 1 plus 0.084 over 4 to the 48. Remember, that was 4 times 12, plus 1 plus 0.096. That was the other interest compounded monthly. So that's 12 times 12, 144. And this is equal to that term left over. That was the 150,000, 1 plus 0.084 over 4 to the 48. Okay, so again, we've still got this B term we're trying to find, but now we can just divide through and finally find what it is. So B is equal to 69,390.95. Nice. So we've got that. Now we want to find A. Now we don't need to do any complicated working to find A, because we know that the sum of A and B is 150,000. We've got B, we can find A. So A is going to be the 150,000, that was the total, minus 69,390.95. That's going to be the leftover that goes into A. So that's going to be 80,609.05. Okay, so we've got the amount going into account A and the amount going into account B. Okay, and all of this was done because we wanted the two account values to be equal. Okay, so whatever was put in the one account, whatever was put in the other, at the end of the full period, we want those to be the same. So that is the reason for this equal sign over here. Okay, any questions on this one? Okay, no questions. If you do have questions later on, please go ahead and use that email link, also that email address. Okay, so then there's people there that can help you with any questions. So not specifically this, but anything that you need help with for the exam. Okay, so that's it for our paper 1 sessions. On Saturday, we're going to have our paper 2 session. For the first half, we are going to go through trig. Okay, so all the nice trig stuff. So that will be about an hour. And then for the second half, we will go through analytical geometry. Okay, so about an hour each. Okay, with the same 5-minute break. Okay, are there any questions about the plan for Saturday? Okay, cool. Yes, you've got a question?
Hello? Hello?
Hello? Yeah.
Hello? Okay, I just want to find out, are you able to email us the recordings of all the sessions?
Oh, the recordings will be posted on YouTube. So UKZN has a YouTube channel, and everything should be posted there for you to watch.
Okay,
there is
thank
a
you.
link for these. There is a link for these notes that we've been going through. So all of this working, there is a link available if you want to download the PDFs as well. Okay, so these PDFs, as well as the recordings, you should be able to get that.
Thank you very much. Thank you very much.
Okay, sure. Okay, yeah, so please, just before you go, please can you fill in the register? Okay, so there's a link to the register there. It shouldn't take you too long. So please, can you just do that for us?